Welcome back to Learning SQL, everyone. Let's have some fun building some charts. So if you're thinking about getting into data analytics or using tools like Power BI to take your SQL and create live dashboards, this episode is going to be all about some practice problems and turning them into charts inside of Hex. Now, these concepts are applicable to Microsoft Excel, Power BI, any business intelligence tool. But Hex has everything built in, so let's write some SQL with the intention of building some visualizations. So real quick, we'll do an example. I'm going to show a bar chart of the number of resources per operation. So we've wrote this query before. Let's just do a quick setup. We're going to select star from MES resources, and we'll call that R. Okay, and we're going to inner join to MES operations. We'll call that O. And let's start it on r.operation ID equals o.id. So again, if you're not familiar with this syntax, I recommend you go back a few videos and make sure you're comfortable with joins. We are now returning a data set that looks like so. And if you've done charts in Excel or any other tool before, you know that with a tabular data set like this, you can throw it into a charting tool, which conveniently Hex already has built in. Now, what I want to do is get away from some of these defaults, and let's actually start blank just so I can take you through my thought process. The x-axis, right, we want the number of resources per operation. So the x-axis in this case is going to be the operation name, and we want the y-axis to show a bar chart where the height is the count of the rows in this resources table. So what we're going to do is use anything from the resources table. Maybe we'll use the resource name, and right away Hex is going to figure some things out, and we have built a chart for each operation name and how many resources it has. So you can obviously add titles. I'm sure you can sort by, I won't get into it, but I'm sure if you want to play around, you can sort from highest to lowest. You can change the colors. All sorts of stuff is possible in Hex and many other BI tools, but for this series, I just want to focus on the concept. Now, one thing to point out here, and this is a common struggle in the world of being an analytics or business intelligence developer, we could have performed this aggregation in our SQL. As we've learned, it's very easy to change this query. So it would be operation name and then count. We'll call that as num resources. And then group by o.operation name. And when we run this, and maybe just switch back to preview, we're going to get the same final data. And we can go back to this chart builder. And again, let's clear everything out. And this time, our x-axis will also be the operation name. And our y-axis is going to be this num resources. And because it's a numeric column, Hex is actually making an educated guess that we want to use a sum. We could use the max. In this case, it wouldn't matter because our data looks like this. So we could use the mean, et cetera, et cetera. But I want to point out this sort of two distinct ways of getting to your final result. This way performs more of the calculations at the warehouse level. So for very intensive aggregations, it can be more optimal to write a query like this and then just pass the cleaned data into the charting library. So for example, if you're doing massive pivot table type things in Power BI, the dashboard's going to run a little slow. SQL is much more optimized to process that kind of load. However, the previous example that I showed with just a much simpler setup can be nice because it offers a lot of flexibility for customizing things purely in the BI tool. So both are sometimes good. It depends who you're working with, what you're doing, etc. But just want to make sure you guys are aware. Okay, so let's do a similar type of problem just to make sure you're following, you're still able to get those joins down, and let's build a chart showing the number of completes by operator. So you're going to take the complete log, you're going to connect it to the operator table to get the operator name, and then let's build a bar chart showing the number of rows in that output. Pause now. Okay, so here we're going to start, same as always, with select star from, and let's start with the complete logs table. We'll call that CL, and let's inner join to MES operators O on, and if we just quickly peek at the table, we can see in the complete logs there's operator ID, and if we find that operator table, there's a column called ID. So we know on CL.operator ID equals O.ID. Let's clean this up, and we know now that when we run this whole query, we will get a long list, and we can bounce over to our charting tool. Hex is going to make an educated guess about what you're trying to do. In this case, it was pretty close, but it seems to be summing the ID because the ID in our case is a number. What we actually want to do is just switch this to a count. And so now we will see which of our operators completed how many completes. You can rename these, and then again, you can always go back and rewrite this query to perform more of the processing in the data warehouse, so with your syntax. But should be comfortable with what these concepts are. Let's keep on rolling, and I want to talk about a new syntax called the union. So I bring this up specifically because it's very useful when you're doing business intelligence reports, specifically for situations where you want to stack data on top of one another. And that's exactly what a union does. So let's do a quick example. I'm going to select star from, let's say, MES complete logs. Okay. And we know what this table looks like from experience, but maybe let's just pull a few columns, ID, operator ID, and let's get a more down selected version. So let's also pull work order ID. Oh man. And let's clean this up. Okay, I like to write my queries nice and neat before I get too far along. It helps me stay focused on, it helps me just keep up with how I'm working through the problem. So if we select these three columns, I want to filter this down to only look at one work order. So let's maybe look at this first work order. So I'm going to add a filter where work order ID equals that number. And we should get 3 to 5 results here. 5. Perfect. Now, we know that the complete logs and the scrap logs tables are actually very similar, right? So if I pull from MES scrap logs instead of MES complete logs, the results are going to look very similar. Maybe let's add in the quantity so we have a little bit of something different to look at. Right, so these scrap quantities are pretty low, but the complete logs are going to be completing much more, right? We have good yields on this work order. What would be really cool is to be able to show this data set in one vertically stacked table. So what we can actually do is use this union concept, right? So I'm going to put two SQL queries on top of one another, and I can put this syntax in the middle of them, union, right? So I didn't change the complete logs yet, but if I run this whole thing, we're going to get the same data set stacked on top of each other. Sorry, there is an intricacy here. So let's go with union all. I guess while I made that quick mistake, it's worth explaining. Union all is going to basically joined two outputs together, or I shouldn't use the word join. It's going to stack the two outputs on top of each other. The reason that the union actually didn't return anything is because if you don't use union all, it's going to remove any duplicates. So that was actually a very good example to understand union versus union all. Since we're stacking the same records twice, right? So this fifth indexed row is the same as the 0th row. The union without union all was removing duplicates. So we're going to use union all. In a second, it won't matter, right? So when I move this from the complete logs to the scrap logs, we're now getting a bunch of different records, and this represents the 5 scraps that took place. So again, let's start to add in some columns. Maybe we want the resource ID that we could later join to either the operation or just the name of the resource. And we're going to continue to be able to stack these two tables on top of each other. Now, one thing to be careful of with unions is if your top data set has an additional column, maybe the timestamp, you're going to get an error. This union, or a union all in this case, requires that the same number of columns is in the bottom query as the top query. Okay? So I don't want that timestamp. Let's run everything one more time. And one final piece of this that's going to require a good understanding of the real basics of SQL is that we want to label these columns differently. Now, there's nothing in these tables that tells us if it's a scrap or a complete. But we, as the writer of this query, can add anything we want as a column. So what we can do is add a complete column, and we'll call this maybe type. Okay? And in this bottom area, we can do scrap as type. And so when we run this whole query, it's going to stack them on top of each other, and each of these smaller queries has an extra column that we hard-coded. And you'll see why this is important and why I'm bringing up this whole concept in this video. Now we have something that we can bring to a stacked bar chart. So if we go to the charting section, and we want to show the resource ID as this work order moved from step to step, and we want to stack the complete quantity on top of the scrap quantity. So what we can do, we'll use the resource ID as the x-axis, and we can sum the columns. This is worth noting. So Hex, again, is seeing our IDs as a number because they are just integers. We want to switch these IDs to a string value. That way Hex thinks of them as groups and not as a number along a range of numbers, right? So now we just have our 5 resources. And as of right now, we are summing the entire quantity. But what we really want to do is show a stacked bar chart here. And so we can add a grouping on this type. And so right away, we'll see the complete and the scrap. Okay, so you see the scrap quantity is now stacked on top. And we can very quickly look at a resource and view how much was scrapped at that resource. Okay, maybe you'd want to switch this to descending. And so now we can look and see how much quantity, and we probably would want to sort by maybe this. Right, so we can see we probably started with a full 2200 work order. We scrapped some, and then as you walk down the line, you're seeing the order of operations where we lost material over the course of this work order. And then you can obviously apply everything that we did here at the aggregate level. So if we remove the specific work order filter, this same chart is possible at the much, much higher level. And so this isn't as chronological, but we can see which operations we're working with, or sorry, which resources we're working with the most quantity and which ones we're scrapping the most. Okay? So take that same concept that we just did, you might need to rewind the video, and build a stacked bar chart showing the amount of scraps and completes for the inspection station by week. So instead of our x-axis being the resource, let's set the timestamp value, and we're going to need to use that extract function that we learned previously as our x-axis. Take a pause, give it a go, and I'll be right back. Okay, so we're going to apply some similar processing as above. So of my own laziness, I'm going to copy everything that we used up here. And now we have a data set to work with. Now, the most important thing here, we no longer need a lot of these columns, right? When you're building a chart, you usually only need 3 or 4 columns, sometimes even 2. So let's take everything out that we don't need, right? We just need the quantity, the type will be important for that stacked chart. And now we need to extract the week from timestamp, and we'll call this week of. So this new column, we need to make sure it's in both of our subsections, is going to allow us to use the week of as the x-axis and then sum those quantities for each of those x-axes. So now I'm doing this analysis and I can create a chart, and we're going to set our x-axis in this menu to be that week of. So things should go in an increasing order, hopefully. And then our y-axis is going to be the quantity column. Okay, so we can see, looks to be going well. And finally, if we use this group by area, when I hit type, we now see, okay, and it's doing a grouped column, which is fine. Sometimes that's what you want. We'll go ahead and do a stacked column. So everything will pile on top. And this data set is starting to show which weeks we did the most processing, maybe which weeks we had the most scrap,